Come back to Calculus 3. In this part, we will continue to talk about functions of two variables. And hopefully see a function of two variables really would represent a surface. The situation is more complicated. Certainly for now, I hope you have some rough idea. And we may have the surface as a sphere, or the surface as a paraboloid, or in a very simple case, the surface just turns out to be a plane. A linear function in the three-dimensional space represents a plane, not a line anymore. Okay. And now, hopefully, you can tell many times it is not that easy to figure out, how the surface, and certainly, as I'm saying, for now, we are considering those very simple cases. Maybe we are familiar with the situation, we can get the graph. And many times, it's just hard to figure out how the surface would look like in the 3D space. So we do have some ways, some have tools or mechanisms to manipulate the graph or just to help visualize how the surface would look like. So the next part, it is the concept of level curve. A function of two variables would represent a surface. A level curve, it is generated simply by setting the function as a constant. To see if it really makes sense to you, okay. In the beginning, we are having three variables. Now, by setting the function as a constant, really, we only have two variables, right? So that is the situation in the xy plane. And that would represent a curve. And that curve, it is called as a level curve. And the collection of level curves forms a contour map. Okay. How about let's go back and look at the example we just did. See, remember this graph. The graph is sphere, right? It is generated by squaring both sides. So we got the equation of sphere, and also we understand that the function value will have to be always positive. So it is the upper half of sphere centered around the origin. Okay. And now this time you can give a try. Let's say if we set this entire function equal to 0. And then you square both sides, you're having x squared minus y squared equals 9, which is really this blue circle. The blue circle, it is generated by setting this entire equation equal to 0. It's a circle of radius 3. And also, a level curve. You could have many different level curves. You set the constant equal to 0, you get the blue circle, or maybe you could set the constant equal to 2. And then if that is the case, I hope you will see you still need to square both sides when you set the constant at 2. And then what you are going to have here is it's the equation of circle. It's the equation of circle centered at the origin with radius square root of 5. And also you could try to set out the constant as 1. And then if that case, you're going to have this orange circle here, And certainly if you are interested or if you still don't see anything, you can draw more level curves. And all the level curves together, it forms a contour map. This is a contour map. And then you may wonder, how do we go from the contour map to the actual surface? Well, remember we said the actual surface, it is the upper half of the sphere, right? For this one, upper half of the sphere, okay. And indeed, what I'm seeing here is we can say in this case, the sphere also can be considered formed as by stacking circles. So at a certain point along the z-axis, moving downward at the z-axis equals 3, and then moving downward, the circles getting smaller and smaller. Okay, so this is the contour map of example 4.2 part A. And surprisingly, in terms of contour map, this graph, the function here, function in part B, Also, it is a collection of circles. But anyway, this time the situation with circle, it is formed a little different way. You can consider you are stacking circles around the z-axis going upward. As you move up, and the circles getting bigger and bigger. So indeed, the contour map of this function, it is still about the circles centered around the z-axis. And as you move up, the circles getting big. And for the sphere part, we have circles, and when you move downward, when you move down those circles downward, the radius of the circle or circles are getting bigger, getting big. Okay. How about let's look at another example. Then we say this is linear function, right? So how the level curves or the contour map would look like. So I did give a try to form some linear curves, level curves, and the contour map. So this is the linear function. We understand that it is a plane. So by setting this linear function equal to constant, let's say I'm setting this as 0. So indeed, I would have a line like this with the x-intercept 3, y-intercept 2. And also, you can take any constant. When I set this function equal to 6, I'm having a line passing through the origin, okay, like this. And also, if I set this function as 12, I'm having a line like this. And also, I hope you realize all those lines are parallel lines. Parallel lines. And if you understand the situation, well, this is, I would say, you don't have to bother for the plane. You see the plane clearly, you don't need to bother about the contour map or level curves at all. But anyway, I think if you have the plane in your mind already, I say somewhat you can visualize how the plane is formed. I'm seeing basically you are stacking those lines, and then in a way somewhat getting closer and closer to the z-axis, and then it will have to form like this. And so this is how I would like to visualize how you consider how to visualize the surface in the three-dimensional space. Usually it is hard, and certainly I would say for the examples I did on the notes, they are very simple ones. But anyway, I hope you are convinced using contour map, it will help visualize the actual surface. Okay. I want to do one more example. This example, it is from the textbook. It is asking for the level curve of this given function with a given value, constant equal to 15. So this is what I did, setting this entire function to 15. And also remember the technique called completing square. I know x squared minus 6x together can be used to form a square if I add number 9. Y squared plus 2y together can be used to form a perfect square if I add number 1 here. Okay, I added 2 extra numbers to the left, which means I'll have to do the same for the right hand side. And the reason I'm adding those 2 numbers to the left hand side, because the first number will help me form a perfect square. Second number, indeed, is serving the same purpose, another perfect square. Certainly, right hand side simply can be merged as 25. So I'm seeing this turned out to be the equation of a circle centered at 3 and a negative 1 with radius 5. Okay. So the level curve here with constant equals 15, it is a circle centered at 3 and a negative 1 with radius 5. And also, indeed, if you are thinking about the contour map, I would say the contour map will be the bunch of circles centered at the same point, the concentric circles, certainly with different radius. I think this is the beginning part of 4.1, function of two or 3 or more variables. But anyway, for our purpose, mostly we will consider function of 2 variables. Thank you for watching.